Alright, page 2. So here we have a few properties of addition and scalar multiplication. Here you know that the community property of addition, matrix addition, works, as well as the associative property of matrix addition is also okay. The associative property of scalar multiplication works. The grouping doesn't matter. We can multiply C times D first, then times A, or we can multiply D times A first, then by C. We're still going to get the same matrix, the matrix multiplication on both sides. And then here you see that the distributor property works for scalar multiplication with matrix addition. Now, for matrix multiplication, in order to do matrix multiplication, you have to make sure you know how to name each matrix. Remember, you do it by rows, by columns. Now, the reason why it's important is because when you're doing matrix multiplication, what has to happen is that the columns of the first matrix has to equal the rows of the second matrix. And the reason why that is because we're going to be multiplying rows by columns, rows by columns. And so, because we're doing that, the rows and the columns of the first matrix has to match the rows of the second matrix. So the best way to see that is, with an example. So here I'm going to show you an example. So here is example 3. We have two matrices, an A and a B. Matrix A is going to be I'm going to multiply that by B, so that's important. A comes first, then B, so I'm going to name A first. Now, A is named by a 1 by 4, or defined by a 1 by 4. 1 row, 4 columns. Matrix B is defined by 4 rows and 1 column. So now, because the middle matches up, I can do matrix multiplication. And the outsides are going to tell you what type of matrix is going to be formed by the matrix multiplication. I'm going to have a 1 by 1 matrix after I do my multiplication. So when I name it, the columns of the first matrix has to match the rows of the second matrix. If that happens, then the rows of the first matrix and the columns of the second matrix are going to make up my product. So here I have A times B. So what I'm going to do is I'm going to multiply my rows by all the elements in my columns. So I have 1 times 3, plus -1 times -5, plus 0 times 1, plus 4 times -1. And then that's it. There's no more columns or rows to multiply. And so I add up all of these products, and I'm going to be left with 3 plus 5 plus 0 plus -4, or just 4. And that gives me about 1 by row matrix. Alright, so now, for example 4, we want to do 2 parts. We want to find AB and we want to find BA. And here you're going to see that for matrix multiplication, it is not commutative. The order does matter. Alright, so here we have matrix A, which is defined by 3 rows and 2 columns. Matrix B is defined by 2 rows and 3 columns. So if I'm going to do A times B first, the middle has to match. 3 by 2 times a 2 by 3, I have the 2's on the inside, and so my matrix that's going to be formed from the matrix multiplication is going to be a 3 by 3, so a square matrix. And so how you multiply matrices is, again, you're going to multiply all the elements you're going to take all the elements of the first row and you're going to multiply each element of each column. And so we'll multiply 3 times 1 plus 0 times 2, and that's going to be the first element of my matrix. Then I'm going to multiply 3 times -1 and 0 times -5. So I'm multiplying the first row by every column. And every time I do that, I add up the elements in the column after I multiply. So this will be, the last part will be 3 times 0 plus 0 times -1, and that's going to be defined there. And then I keep doing that for each row. And so now the next row for my solution is going to be the second row of the first matrix times every column of the second matrix, and that's going to define every element in the second row of my final matrix. And then do the same thing, the last row times every column. I'm just going to make those up. When you multiply and add all those together, the product of AB is 3, -3, 0, 3, -6, 1, and -1, 1, 0. Now, for B times A, I now have to put B in front. B is a 2 by 3 times A, a 3 by 2. The 3's match up, so I can do matrix multiplication, and my product of B times A will result in a 2 by 2 matrix. So again, I'm going to do the same thing. I'm going to take every row and multiply it by every column. So 1 times 3, -1 times 1, 0 times -1, and that's going to be the first element. And then the second one for the first row, I'm going to take this row times the second column. 1 times 0, -1 times 1, 0 times 0. And I'm finished, and then I move on to the second row of B, and I multiply it by every element for each column. So B times A first column, second row of B times the second column of A. And you add each product up, and you get for B times A 2, -1, 0, -5.